In this video, we will continue graphing trig function cosecant. Again, all this information is pretty much shared with the other trig functions. If you watch the secant video, we talked about why this amplitude is not really considered an amplitude. It does affect how far away these alternating U shapes are from the x-axis, but we won't necessarily call it an amplitude. Again, phase shifts, vertical shifts, period, again, 2 pi divided by k. The domain is all real numbers except x cannot equal any multiple of pi. So with cosecant, the first vertical asymptote going from 0, the first vertical asymptote is going to happen at pi. And then any multiple of pi, whole multiple of pi, 2 pi, 3 pi, 0 pi, we've got a vertical asymptote there, negative 1 pi, any multiple of pi, there will be a vertical asymptote in this graph. And that's because cosecant is reciprocal of sine, and sine is 0 at any multiple of pi. So if you think about your unit circle, on the left side of the unit circle, on the right side of the unit circle, the sine values there are 0, and those represent all whole multiples of pi. So that's where we're going to have vertical asymptotes with cosecant. So I'm going to jump right into the first example here. The amplitude of this graph is 1. The period is 2 pi divided by k, which is 2 pi. There is no phase shift, and there is no vertical shift. To make my xy table, again, period is 2 pi here, so we're going to go from 0 to 2 pi, and I will fill in the values in between. So just like with secant, we thought about graphing the cosine function. With cosecant, we're actually going to think about graphing the sine function. So let me label these out really quickly. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then our y-axis, I'm going to go 1 and negative 1. And what I'm going to do is, because cosecant is the reciprocal of sine, I am going to go ahead and graph this as if it were a sine function. So with the sine function, we started at 0, and then we go up to 1, and then we go back to 0, and then down to negative 1, and then back to 0. So those would be the points that we would use if we graphed sine. Just like secant and cosine, with cosecant, it's going to be undefined everywhere that sine is 0. So every place that sine hit the x-axis, those are going to be vertical asymptotes. So we have vertical asymptote at 0, at pi, at 2 pi, and then what we have is these other locations. If sine is 1, which happens at pi over 2, then cosecant is also 1 there, and we get this u that goes up. And then if sine is negative 1, cosecant is also negative 1 there, and we get this graph that goes down. And then again, it's undefined at all of the places where sine would be 0, which happens at 0, pi, and 2 pi from those 5 values. But again, at any multiple of pi, you will have a vertical asymptote. And we get these alternating U shapes. The next one would be up, the next asymptote would happen at 3 pi, and so forth. And that's the quick way to graph cosecant. So let's look at another example. This one has a phase shift. So our amplitude is 1. The period, again, is 2 pi. There is a phase shift. We are taking this graph 3 pi over 2, and since it's addition, that means to the left. We're taking this graph 3 pi over 2 to the left, and there is no vertical shift. So if we are going 3 pi over 2 to the left, our first x value that we are going to use is negative 3 pi over 2. And then keep in mind, to get the rest of these x values, we want the length between the first one and the last one to be the length of the period. So I need to take negative 3 pi over 2, and I need to add 2 pi to it. And if I do that, that gives me pi over 2. So that is going to be our last x value. So then if we tried filling in between there, halfway in between negative 3 pi over 2 and pi over 2 would be negative pi over 2. halfway between negative 3 pi over 2 and negative pi over 2 would be negative pi, and halfway between negative pi over 2 and positive pi over 2 would be 0. So I'm going to go ahead and label this out. Now, most of my x values here are in the negatives, but I do use 0, and I'm going to just go over 2 boxes here to get my pi over 2, which means negative pi over 2 is going to be here, negative pi will be here, and negative 3 pi over 2 will be here. So again, most of this is going to happen to the left of the y-axis. Totally fine, as long as you remember how to find those x values and understand what that phase shift does. Since there's no amplitude change, again, I'm only going to go 1 and negative 1 on the y-axis. And just like before, I'm going to say, well, if this were a sine graph, I would start at 0, I would go up to 1, I would go back to 0, I'd go down to negative 1, and I'd go back to 0, which means we have vertical asymptotes at negative 3 pi over 2, at negative pi over 2, and at pi over 2. Everywhere that the sine graph hit the x-axis, those are our vertical asymptotes, and then we're going to go up at negative pi, and we're going to go down at 0, and we've got our graph. So if you can easily graph cosine and sine, you can also easily graph secant and cosecant.